Today's lesson is on rate of change and slope. Before we get started, I want you to understand what we're referring to when we talk about slope. Slope is the steepness of a line. So here we have a very steep slope, and here it's not as steep. But what both of these lines do have in common is that they are both positive slopes, because when you're looking at a line, you want to, like always, read from left to right. So as we look at these from left to right, they are both going up, they're increasing, so that would be a positive slope. Whereas here, again, this one's steeper than this one, but they are both negative slopes, because when we read from left to right, they're both going down. Okay, so make sure you write this down. Here we're talking about rate of change. Rate of change is the change in the dependent variable divided by the change in the independent variable. And remember, when we talk about the dependent variable, we're referring to the y value, and the independent variable is the x. Also, I put in here rate of change is simply the slope. Okay, how much is that line changing? Now notice here, I'm not done yet with this, because we're not just talking about y over x, we're talking about the change in y over the change in x. So to figure that out, you need to subtract, which would be y minus y in the numerator and x minus x in the denominator. However, notice I have the 2 and the 1 here with the y value and the x value. That's not multiplication. It's not y times 2 minus y times 1. It's just indicating, okay, this is your second y value minus your first y value. It's just indicating which one it is, and I'll show you an example of that in a second here. Another name that we can use to describe this is, you might have heard this before, rise over run. So the rise is the change in the y value, and again, you'll see this in a minute, just write it down for now. And the run is the change in the x value. Okay, so here it says find the slope of the line through the point -2, 1 and 5, 7. So just picture that on a graph. Okay, if we had a quick graph here, -2, 1 would be somewhere here, 5, 7 would be here. We're trying to figure out what's the slope of that line that looks like this. So the way we do that is we take the change in the y over the change in the x. So first, let's indicate which ones are our x values. I color-coded it here. -2 and 5 are the x values. Be careful. Those go in the denominator. 1 and 7 are our y values. Those go in the numerator. So what I did here is I took my y values, the 1 and the 7. It doesn't matter which one you put first. I decided to put the 7 first, 7 minus 1. But because I put the 7 first in the numerator, that means that I need to put the 5 first in the denominator. So when I subtract those two numbers, it's going to be 5 minus -2. I could have done the exact opposite and I would have gotten the same answer, 1 minus 7, but then in the denominator I would have -2 minus 5. So just make sure the order is the same, okay? And then we simply solve. So 7 minus 1 is 6, and 5 minus -2 is 7. So the slope is 6 over 7. Now let's take that same problem and do it with a graph here. So I graphed the two ordered pairs that we were just referring to. -2, 1 is right here, and 5, 7 is right here. The other way to do this, you could do exactly what we just did, take the y values and subtract them over the x values, but you could just count, if you had a graph, the rise over the run. So the rise is the change in the y value. Well, remember, your y is your vertical line, and then the run is the change in the x value. Well, your x is your horizontal line. So we're going to count the rise first. We are going up, so this will be positive. 1, 2, 3, 4, 5, 6. So 6 is in my numerator. And then I need to go to the right. That's also positive. So 1, 2, 3, 4, 5, 6, 7. 6 over 7 was the same answer we got here. Same numbers, just two different ways of doing it, depending on whether they give you the ordered pairs or whether they give you the graph. That's it for today, guys. Bye-bye.